Give it about a minute for people to trickle in, and then I'll get started. Okay, hide this. Okie dokie. I'm gonna go ahead and get started. So at this point, just some logistics. So by now, you should have turned in homework 2. You should have done a peer review. I haven't actually taken a look at them yet because I've been busy so far today, but I'll take a peek at them. I'll send an email out if I notice some systematic issues with it or anything like that. Of course, as usual, feel free to ask me questions in Slack, shoot me emails, whatever you're comfortable with. And then during this lecture, of course, I'll read out any questions that pop up in chat, try and send them globally rather than to me privately. If you raise hands, I'll try and see them up in the little thing over there. Anybody have any sort of general questions before I get started? Okie dokie, then I will get started. Okay, so the theme for today is death to spreadsheets. So a lot of people use Excel for data manipulation, sometimes for analysis. They use it as sort of a primary tool in their sort of working with data environment. I think you should not do that, and you should stop doing that. So the theme for today is going to be death to Excel, or rid of Excel. We're going to talk about how to do all the things that somebody might normally do in a piece of spreadsheet software more transparently, reproducibly, and safely, using especially dplyr today, but sort of the rest of the course, the other tools will be for similar things too. As the years go by, people become less and less familiar with this story, but an idea here is you do not want to be the next sad research assistant who makes headlines like this Reinhardt and Rogoff paper. This was a fairly well-known problem that basically there was a high-profile paper by Reinhardt and Rogoff showing that GDP to debt ratios, like really high debt to GDP ratios, slow growth in sort of developed countries. Well, it turns out that the relationship in that particular paper was due to a research assistant making a mistake in an Excel spreadsheet formula that left out like a third of the data from a calculation. Okay, so you don't want to be in that position. You want to have algorithmically sort of generated values and things, and you want them to be reproducible, not hidden somewhere deep in an Excel formula that was generated by a point and click interface where you drag down a bunch of columns and just happen to miss a few of them. Okay. So today is mostly going to be using the dplyr package. I'm going to begin here by talking about modifying data frames. We've done some of this. We did a bunch of it in lab, actually. So a fair number of things I'm going to talk about today, we kind of pre-covered in lab, which is typical. People usually want to know how to do a little bit more than I show them. And so I end up jumping onto my next lecture ahead of time. Anyway, okay. Before I get into modifying data frames, I want to go back over pipes just a little bit. So dplyr uses, as I've mentioned before, the Magrider forward pipe operator, which most people in the R world usually just call a pipe. We write pipes like percentage greater than percentage, and you can insert them in your documents using Control-Shift-M, or I assume Command-Shift-M for Macs. Okay. So the way pipes work is they take whatever object or calculation is on the left side of the pipe and they apply the function on the right side of the pipe to it, okay? So whenever you see a pipe in your code, you can usually read that pipe out loud as the words "and then." So I'll give you an example here. If we've loaded up dplyr in the gapminder package, we would say, take the gapminder data and then filter so that country is equal to Canada, and then take the head 2 values of that data set. There we get the head to values where the data have been filtered down to the country Canada. Okay. Okay. Pipes are nice because they save us typing. One way they save us typing is instead of creating lots of intermediate objects, we just do something and then attach something onto the end of it, right? So instead of doing gapminder filter country equals Canada and writing it to a Canada object and then doing head Canada too, we just pipe it straight into that head command. We write a little bit less. And then the really nice thing is just this general approach of chaining. So as you start to do more and more and more operations on a data set, chaining becomes more and more intuitive and more beneficial. Instead of creating lots of intermediate objects, you just sort of do one step to get your data a little closer to where you want, and then you keep doing more and more steps until it gets to be what you're after, right? So most of the projects that I do, and I'll probably show some examples over the term, most of the projects that I do, my data manipulation for, say, an entire data set is actually done in one chain of pipes. There might be 30, 40, 100 commands in a row, but no objects are created, just runs through one chain. I didn't write all 30, 40, or 100 of those things in one go. I did it one line at a time. I run one line. Oh, that looks to be what I want. I write the next line. I just keep adding on to it. Okay. So this is kind of like ggplot, where you'll add on a layer. You'll kind of like how that looks, but you need to modify something. You add another layer, you add another layer, you tweak a parameter, something like that. Same thing with these pipes. It's this additive way of doing data manipulation rather than visualization. Okay. So using pipes. Pipes are clearest to read when you have each function that you pipe into on its own line. That way you're kind of just reading this line, then this line, then this line. I'm a little inconsistent in my class because there's a lack of space in the slides. So sometimes I'll put a couple short things on one line, but normally I recommend in your own stuff, it's much better to have a document highly vertical than at all horizontal. So just kind of stacking things up and down is usually the best way. It's kind of the same thing with ggplot. Okay, so again, with pipes, you can sort of think of them like this. You'll probably begin with some data frame, some object like that. You'll say, take these data and then do this first thing, maybe with some value, and then do the next thing using some other value, and then do a third thing, and then do a fourth thing, and then do a fifth thing, until you run out of things that you want to do. Never creating an object or anything like that in the process. You're just spitting them down, these functions, and then assigning them to something if you want to keep that. Okay, so again, stuff to the left of the pipe is passed to the first argument of the function on the right. Any additional arguments to that function will go after or go inside the function itself. If you ever find yourself piping a function, piping into a function where the data are not the first argument, but you are piping in data, you can tell the pipe where to put the thing you're piping in using a period. So for instance, the linear model function in R, LM, does not take as its first argument the data. It takes instead a regression formula. For instance, in this example, I'm regressing population on year. But what I want to do is I want to do it using, say, Yugoslavia, an object that I will create in a couple slides. It's just the former Yugoslavian countries. Okay, so if I want to run this linear regression on these data, what I need to do is say, take the Yugoslavia data and then run a linear model of population on year, data equals period. This says send that Yugoslavia object over there where the period is into the data argument. Okay. Most functions in dplyr and the tidyverse take data as their first argument, including ggplot. The ggplot object, it takes data as its first argument for this reason, so you can pipe things straight into it. Sometimes, especially base R functions, take data as one of the later arguments in it. If you want to pipe into it, you'll need to use a method like this. Okay. So, when you want to create a new object from the output of some piped functions, you normally put the assignment operator and the object you want to create at the beginning of the pipe chain here. So for instance, if I want to create the object, the results of a linear regression of population on year, what I'm going to say is make an object called lm pop year. Assign to that the Gapminder data, and then filtered to continent is Americas, and then a linear regression of population on year. And this would be linear regression of population on year for the countries in the Americas. And that all, no matter how many lines there are of piped stuff, gets assigned back up to the top. So this lets you specify what you want to make first and then tell it how to make it, which is probably how you think about these things also. Okay, so I have a question over here. Why do you need to pipe Yugoslavia if you're using the Yugoslavia data? So this was back here. Was this one? I could instead say data equals Yugoslavia and not pipe it in. This is just sort of a toy example. But here I've made an object called Yugoslavia, and if I want to send it into LM, I have to pipe it in this way. Does that answer your question, or do you have something else?
I guess what I'm confused about is what exactly you're piping. Like, to me, it seems that the Yugoslavia at the beginning and the period representing Yugoslavia are redundant. So what makes them not redundant?
So if I didn't, are you asking what would happen if I didn't have data equals period, or are you asking what would happen if I took Yugoslavia out?
If you took the first Yugoslavia out and just did LM pop year, data equals Yugoslavia, what's the difference between that and what you have?
There would be literally no difference. The idea, however, is what if you want to do what we're doing on this next side, where you begin with a data set here, do some operation on it, and then you run a model on it. This is where it becomes useful. So instead of having to create some object of the Americas and then put that object there, I can do an arbitrary number of calculations and then send them straight into that model. So it's just a different way to represent the same operation, but it is identical.
Okay, thank you.
Yeah. Okay. Yeah, so no matter how long your chain of functions is, you normally always do the assignment up at the top like this. There are some people who prefer to do their assignment at the end of the chains, and you can do that, but you have to use the assignment operator that points the other way, which is a rarely seen creature in the R world. But every once in a while, you'll see somebody online who does it that way. They are a strange person, but they exist. Okay. So a function we've seen from dplyr already from last week was filtering. Filtering rows or subsetting to rows is done with the filter command in dplyr, right? So if I want to create an object called Canada, which is just the observations from Canada and the data, I can say, take the object Canada, assign to it Gapminder data, and then filter it so that country is equal to Canada. If I get the head of Canada, all our observations are from Canada, as one would expect. Okay, so this is an operation we did in the homework, probably, and I showed a little bit in the last lecture. The Excel analog to this is also the filter command or filter statements in Excel, which would select specific rows in the spreadsheet. Okay, so there's an operator, which I've shown in lab, and I may have shown in lecture, I'm not positive, that is super useful. It is the, I call it the %in operator, or just the in operator. What this is it allows you to do a logical test of something equaling one of any number of objects in another object. So if you are interested in, say, this example here, where we want to filter down so that country is equal to one of these countries in former Yugoslavia, those countries being Bosnia and Herzegovina, Croatia, Montenegro, Serbia, and Slovenia, because for some reason Macedonia is not in this data set. Anyway, if we want to filter down so that country is one of these, instead of saying country equals Bosnia Herzegovina, or country equals Croatia, or country equals Montenegro, I'm getting tired of saying this, typing it would be just as annoying. We can just say country is in former Yugoslavia. This will return a true in that statement, and thus the associated row with it, if country for that particular row is equal to any of the 5 things in former Yugoslavia. Okay, so this saves us a little bit of typing, but it actually does the same thing as doing a bunch of or statements. Okay, here I say, create this former Yugoslavia object. I filter down so country is in it. I get head, or in this case, I get tail of Yugoslavia. And we see I've got 2 observations from Slovenia. So my filtering seems to have worked.
Can I ask?
Yes.
Yes. So I've seen that kind of used a lot, the C and then the thing, the parentheses. What kind of object is that? Is it always a certain kind of object?
Yeah, so this here, C is used to create vectors in R.
Okay.
C just says combine or concatenate these things into a single vector, okay? So if I copy this right here, pop open R, hopefully mine doesn't take too long to start. Let's see. And hopefully I'm not working on something truly terrible. Nope, okay. Okay, so if I, oh, thought I copied that. Okay, if I just run this object, it would produce this down here. This is a 1, 2, 3, 4, 5 element vector. So a vector is just a one-dimensional object in R where every value is a piece of data of the same type. In this case, it's character data. So if I go like this, I could say former Yugoslavia. If I say, what kind of object is this? It is a character vector. Just means it's filled with text or categorical data. Okay. So here's a question here in chat. So does this %in operator combine those multiple countries into a new variable? No, it does not. All it does is test to see if the thing on the left side is the same as any one of those elements on the right side. What this thing is going to produce, though, is just trues or falses. So if I go back over here, if I say, for instance, Serbia %in former Yugoslavia, it's going to say true. The reason for that is that Serbia here is one of these elements in former Yugoslavia. It returns a single true because there's only one thing being tested. %in just is checking to see if this thing on the left side is the same as anything on the right side. If it's the same as any one thing, it returns a true. You can do this with multiple items, though. If I say Serbia and I'm going to do Macedonia because it's not in my data. It should be in former Yugoslavia, but not in Gapminder. It will return a true for Serbia, but a false for Macedonia because Macedonia is not in this list. %in just produces trues and falses. But the way that filter works in dplyr is it gives you rows producing a true for the statement and drops rows producing a false. Does that make sense? Okay. We'll spend a lot of time.
Just a follow-up question. So I can imagine, so I'm working on getting out of Excel. I realize that it's bad, but I've been using it for a really long time. So one way I could imagine doing this is that for each row in the Gapminder data is a country, a year, and a continent. I can imagine creating a new row where it is a 0 if it's not one of those countries and it's a 1 if it is one of those countries. And I could set up a formula or whatever. Is that what this is effectively doing? Is it creating a new column and applying a true false to each row, or is it something different?
So it's not exactly okay, in a way it is creating something because as you see here, when I run this line, the Serbian Macedonia from Yugoslavia, see how it creates a true and a false. It does create a vector of trues and falses, but it doesn't actually create them in the data frame. It sort of just creates them in the ether. And what it does is it looks at those trues and falses, and then it matches them to the rows in the data. So if you have 100 rows in your data, this statement would produce 100 trues and falses. What it's going to do is that for every time it sees a false, it's going to drop the associated rows. It's not going to create a column or anything in the data set. It's just going to use that as a rule to keep or remove. So it's basically what it's doing is it is sort of creating that column like Excel does with the zeros and the ones. It never actually puts it in the data set that is the spreadsheet. Instead, it just goes straight to the stage of selecting the rows that have ones.
Okay, that makes sense. Thanks.
Yeah, absolutely. And the funny thing is if you ask me 2 on-point sort of Excel metaphors, I actually won't be able to answer because I stopped using Excel a long time ago and I am garbage with it now. So the metaphor won't continue too long. Okay. So
hey, Chuck.
Yeah.
A question regarding the class function. So that function returns the type of each of the things inside that vector, which in the case of your example were characters. Is there a certain function which would return that the data type itself is a vector or an array?
Yeah, so there's a couple things. So isVector is a test to determine what it is. So class, in most cases, would tell you what it is, like if it's a data frame or something, but there's different types of vectors, and they kind of come down to being like character is specifically a type of vector, so it's also communicating that it's a vector. In this case, I think you could also, type of should also return character. Class would normally be the one that you would use, but if you wanted to know if something was a vector, you'd specifically use is.vector.
Okay, gotcha. Because coming from other programming languages, like in Python, when you ask the type of it, it returns like array, which means like vector. Okay.
Yeah, and actually class is doing the same thing. It's just that in R, there isn't just one class of vector. It's not, character is not a subset of like vectors exactly. A class is one, character is one form of vector. There's a lot of different forms of vector. So that is actually the class of it. So it's a little bit.
Okay, gotcha.
Structure. Yeah. So the funny thing is there's like character vectors, but then if something is a list, it's just a list, because lists are sort of one main class for them, which can store any data type. Matrices are sort of this weird thing that sit on the borderline, because matrices can only store one data type, but they're still a class matrix. So then you have to use type of with them. R gets a little fuzzy with these things because it's sort of a weird language. Yeah. The deeper you get into it, the weirder it gets. So there's another question here in the chat.
Thank you.
Elizabeth here says, when you say that it drops the row, what do you mean? Does it permanently delete them? So it deletes them in whatever object you create using that statement. So in this particular example where I've said take the Gapminder data and then filter so country is in former Yugoslavia, I assign this to Yugoslavia. This object now only has the rows where country is one of these countries. But if I assigned this back to Gapminder, then Gapminder would only have those countries. If you assign something back, yes, it can kind of delete them, but you could get that Gapminder object back by reloading the Gapminder library. So in R is a destructive language. If you want to change something, you just overwrite the object. You don't usually make direct changes to things. You usually just kind of make a new object and replace it. There are some exceptions to that in more advanced things that I don't cover in this class where you can mutate in place. Data.table works this way. But normally you just overwrite an object, you're creating a new version, and that's how you would destroy it and replace it. Okay, so continuing on. So a next function in dplyr I want to introduce is the distinct function. What distinct does is it shows you all the unique combinations of any variables you give it. So in this case, I've said, take the Gapminder data and then show me all distinct combinations of continent and year. So here we see in the data that's been produced, I've produced 60 things, and I've gotten like Asia, 1952, 57, 62, 97. We get to the end of these ones and then go to the next continent, like America's 1952 and so on. These are the unique combinations of these two variables, okay? But you'll notice any variable I don't include in here, of course, gets discarded. Okay. So it might be the case that you want to get distinct combinations of things, but you don't want to drop every variable involved. If you want to do that, you can say, take the Gapminder data and then get distinct combinations of continent and year, but keep all remaining columns. You can do this if you want, but keep in mind the results may be misleading. So you'll notice here I said distinct continent and year, and that's Asia 1952. What I get as the country for Asia in 1952 is merely the first country represented by Asia in 1952. So it doesn't make any sense for this to be Afghanistan over China over anything else. Likewise, life expectancy, population, GDP per capita are for Afghanistan. It doesn't make any sense to have those. Normally, if you do distinct and .keep all equals true, it's because you want to go down to the unique continent and year, but every other column is actually the same within the continents and the years. That is, you have duplicates. Okay? But if you need to do this operation, this is how you do it. Okay. Normally, I would recommend not using .keep all equals true. Okay. So sometimes what you want to do is you want to filter your data down to a subset of rows, but you actually just want a random selection of them. If you think about it, what sampling observations of a data set is, like random sampling, is just filtering to a random selection of rows. To do this in dplyr, you have two methods. You have sample n, which will select a number of rows equal to a value you give it, or sample fraction, which will sample a fraction equal to some proportion that you give it, like 0.25 to take 25% of your sample, or 25% of your data, right? Okay. So to do this, here I set a seed. So if you have something like an R Markdown document that has any kind of random process in it, you're randomly generating data, you're randomly sampling, if you want the results to always be the same every time you run it, you can set the random number generator seed, and then as long as you do the commands in the same order, you will get the same results. I do this here to show you you can do it, and so that I always get the same results for the rest of this document. Normally, if you're doing something random that you actually want to be random, you don't set the seed because you want it to be randomly generated. Okay. I won't explain too much about random number generation in R. If you want to have your mind blown up a little bit, you can look at details and set seed. For numbers geeks around here, R, like most statistical software, uses a Mersenne twister for its random number generator, which is a good random number generator. Generally works pretty well. Sometimes you might want to tweak that for certain applications. Anyway, so what I say here is take the Yugoslavia data, but what I want to do is I want to sample a random 6 rows. So I say sample n, size equals 6. I could also just say sample n 6 because size is the first argument. And I want to sample without replacement. So if you sample with replacement, it means you could draw the same row multiple times, okay? If you're doing something like bootstrapping of some kinds, you might want to sample with replacement. If you're doing normal sampling where you just want a random assortment of your rows, you probably do not want replacement, okay? So what I say here is Yugoslavia data, and then sample to 6 observations. And I get 6 random observations. Bosnia and Herzegovina in 1987, and in 1967, Montenegro in 2002, so on and so forth. This is just a random assortment of rows in my data. Make sense? Okay. So, often you'll be working with data and you just want it to appear in a table or just in your data frame or whatever in some particular order. So if you want to, say, sort your data by variables, be they numeric or alphabetical, you can do it with the arrange command. So the way this works is this. I say, take the Yugoslavia data and then arrange it descending in year or ascending in year. So increasing years and descending by population. And it's going to order or arrange them in the order that you provide variables. So the first thing it's going to do is arrange my data by year and ascending. So it begins with 1952, the lowest year in my data, and goes up until it runs out of 1952s and then does 1957. Within the year 1952, it begins at the highest population and works its way down to the lowest population. So we've got ascending years, descending population, and you can sort on any arbitrary number of variables in any combination of ascending to descending order that you want.
I see that you have descending but not ascending. Is ascending the default and you just have to specify if you want it the opposite?
Yep. Yeah, it defaults to ascending, which is sort of the normal way in programming in general. You would sort things normally in ascending order. Start with the low value, go to the high value.
Thanks.
Yeah. Okay. So next thing, we've talked about messing with rows, selecting specific rows and things like that, but you can, of course, also select specific columns in your data set, right? So to include specific columns in your data set, and that is get rid of things, you use the function in dplyr called select. So if I want, say, only the country, year, and population columns in my data set, I can say, take the Yugoslavia data and then select country, year, and population, and then give me the first 4 observations. We see now that our Gapminder data now just has a country, year, and population variables. The way select works is it's positive selection. You say what you want, and anything you don't ask for, it doesn't give it to you, okay? And it also provides it to you in the order that you ask for it. I say country, year, and population. So we see country, year, and population in that order. Okay. So you can also use select to drop columns instead with negative selection. So if instead of saying continent, pop, and life expectancy, I say minus continent, minus pop, minus life expectancy, I get all the columns except continent, pop, and life expectancy, that being country, year, and GDP per capita. Okay? So you can use either positive or negative selection. You obviously can't use both positive and negative selection because they're mutually exclusive. But you can use whichever one you want depending on what you want to do. Very often you just want to get rid of one variable so you can minus it off. Other times you want to keep just a couple of variables, you can do that. Either way works. Okay. So there are helper functions for select to let you select series or groups of columns so you don't have to manually type every single one out. These are functions like starts with, ends with, or contains. You can also give it a range of contiguous columns, like the name of a variable you want to start with, colon, the last variable, and then it will give you those two variables and all variables in between them in the data set. So these helpers are really useful if you have, say, a wide data frame with column names that follow a specific pattern or ordering. So this is an example from the Denver Youth Survey, which is a survey data set which I administer here at the University of Washington for my advisor. So the Denver Youth Survey has, at current count, about 88,000 columns. If you have a data set that has that many columns, you do not want to be manually selecting the ones that you want to keep. That data set is in a wide format, so it only has 1,526 rows, but every person was observed in like 10 different waves and asked a million questions, so you got thousands and thousands of columns. The way I have the data structured are that the variables have names like this. Married 10 was the individual married in the year that they turned 10, which is a thing that doesn't occur too often, but in some populations does. Married 11, 12, 13, 14, 15, 16, 17, 18. So if what I want to do is extract from my data set every variable describing marriage at a given age, I can say, take my Denver Youth Survey, select all columns that start with married. What's going to pop out from that is just the variables that begin with the text married. Okay. Similarly, maybe what I actually want are all the variables in this data set that occurred or that are measured when they were 18 or in the year they turned 18. So for that, I could say, take the Denver Youth Survey and then select variables that end with 18, and then I'll just get the variables 18. So this is something that speaks to the utility of using nice uniform naming schemes in your data sets. If you have lots of variables, but they're uniformly named, you can use all these helpers to grab exactly what you want out of them. It sucks if all your variables are named var 1, 2, 3, 4, 5, 6, 7, 8, 9 to 88,000. Makes it very inconvenient to get things. Okay. So the select function can also be used to rename columns at the same time you select them. So here I say, take the Yugoslavia data and then select life expectancy and rename it to be life expectancy. So here I'm saying, I want a column named life expectancy, which is going to be equal to the old life expectancy column. I get head on my data, and you'll see here, I have a new life expectancy column, but it's all I have, right? Because select uses either positive or negative selection, okay? So in this case, I probably wanted to just rename it, but not drop all the other columns. There's a function with identical syntax to select that doesn't drop or keep variables. It's just for renaming them. It is conveniently named rename. So here I say, take the Yugoslavia data, I'm going to select country, year, and life expectancy, and then I'm going to just rename life expectancy, this life EXP, to life expectancy. Now I keep country and year, but I have my new life expectancy column. So you can use a mix and a match of select and rename to do whatever operations you want, whatever makes the most sense to you at the given time. Okay, does that make sense? These ones aren't too bad. Okay, so some good column naming practices, just to hammer this in one more time. Good column names are self-describing. Do not use inscrutable abbreviations to save yourself typing. In RStudio, there's autocomplete in most of the things you're writing, so you don't have to worry about using short names to save yourself a couple extra keystrokes, right? You hit tab, it usually fills it in. Valid naked column names in R can contain upper or lowercase letters, numbers, periods, and underscores, okay? The only restriction is they must start with a letter or a period, and they must not be some reserved word like true in all caps or if in a lowercase. These are reserved for fundamental logical things in the R language, so you can't assign to them. Sometimes you can, but you shouldn't. Okay. So names are, of course, case sensitive. Year with a capital Y and year with a lowercase y are not the same thing, and R does not see any association between those two things, okay? And autocomplete will usually not work in the case that you've messed up cases. In RStudio, sometimes it works and it kind of gets better over time. Okay. You can, however, include spaces or use these reserved words if you put backticks around them. And again, backticks sit under tilde, that is below escape to the left of 1 and above tab on your keyboard. You can use backticks around something and do whatever you want. Inside of backticks, it's the Wild West for naming things, and I'm going to show some examples. Okay, it can be useful to have, for instance, spaces in your names if you're preparing data for ggplot or Pander, but you don't want to rename the axes or the headings. You can just have them pop up with the spaces in them. This can be kind of handy. I wouldn't recommend it storing all your data with spaces in it, because there's some functions in R that no matter what you do just cannot handle names with spaces in them. But sometimes you'll want this. Here's an example. Okay, so what I'm going to do here is I want to make a nice Pander table of Yugoslavian life expectancy. So what I say here is load up Pander, take the Yugoslavia data, and then filter so that the country is Serbia. Then select just year and the life expectancy column. I want to rename year to be capital Y year because I want it to look nice. And then I say, I want the life expectancy column to be backtick, life space expectancy backtick. This means to R, this whole thing is one object name. So people had a lot of questions for me via email and Slack channel that involved problems with having spaces and object names. This is the solution to your problem if you really want those spaces there. You put backticks around them and you can do what you want. I get the first 5 observations and I send it into a R Markdown style table. Now you'll see the column shows up as life expectancy without the backticks. The backticks are just there to tell R that's what you want the object name to be, but in the actual display, those backticks go away and we get a nice spaced name here, okay? So you can see this would be useful for sending things into ggplot, sending things into tables and stuff like that. You don't have to modify it in the like plot afterwards, you can just send in the spaced name. I would recommend doing this right before the plot, not like earlier in your data manipulation, but you could do it right before it goes into a plot, send it in, and you got it, okay? So if you want to create new columns, this is something I showed a little bit in lab, is if you want to create new columns in dplyr, the function for it is mutate. The one thing I hate about dplyr, the only thing I hate, is that mutate for people who are not already programmers is a weird and confusingly named function. It's like rename, oh, it renames things. Filter at least has an analog Excel. Why do I create new columns with mutate? The reason for it is, in the computer science perspective and programming, mutation does mean like creation or modification of a variable, but nobody who's taking this class for the most part usually knows that. So you just need to learn that mutate means create a new column in your data frame. Okay. So here I'm going to create a couple variables at the same time. I say, take the Yugoslavia data and then filter down so country is equal to Serbia. Select only year, population, and life expectancy columns. Then I want to mutate, that is create new columns. I want to create a column called population or pop million. It is going to be equal to the population divided by a million. So that converts population into population in millions of people. And then I say, I want to create a life expectancy past 40 variable, which is just equal to life expectancy minus 40. I will say as a demographer, if you actually measure life expectancy past 40 this way, I will fight you. But anyway, we can create this fake life expectancy past 40 column. And notice here that you can create an arbitrarily large number of variables in a single mutate call. You don't have to say mutate, make one variable, mutate, make another variable. You can even make a variable here like pop million and then use it in the next statement. The way mutate works is it generates the variables in the order that you write them in the mutate command, so they're immediately usable, say, to generate the next variable. Okay. So now we see here in the data output, we have year, pop, and life expectancy, but now we have my new pop million, which is just equal to this divided by a million, and then life expectancy past 40, which is just this minus 40. Okay. That's how you create variables. It's pretty easy. And you'll notice here that we did a little bit of math to do it. We can run functions up here, do whatever we want, and we can make columns this way. It's actually pretty flexible. Any questions on that? Okay. So a common thing you'll want to do in Mutate, or a common function you want to use in Mutate and generally programming in R, is use the if-else function. This is not to be confused with if and else as two separate functions or objects, but this is one thing if else. What if else does is it will return a vector, a series of values that depend on some logical test. So in the abstract, the way it works here is the output from if else will be some test here will do, say, x equals y. If x does in fact equal y, if else will produce whatever is this first value. If x equals y is false, it will produce the second value. So it will produce either the yes value or the no value. If this test here cannot be done, say you're trying to test if somebody equals NA, which we're going to talk about, if else will also produce an NA, basically when it fails. So to demonstrate how this works, if I create an example vector here, which is just 1, 0, NA, and -2, I could say if else example is greater than 0, return a positive. If it is not greater than 0, return not positive. So I run this statement on example. Well, the number 1 is greater than 0, so it returns positive. The number 0 is not greater than 0, so it returns not positive. NA is neither greater nor lower than 0. It is a missing value, so if else fails and returns an NA. And then -2 is not greater than 0, so it returns not positive. Okay, so this is a way to convert a logical test here, a series of trues and falses, into specific values. Okay, we can see it in action creating a variable here. So if I take my Yugoslavia data. So as an example of what I'm doing here is, if I'm working a lot with Yugoslavia data, I may get tired of saying Bosnia and Herzegovina all of the time. I would prefer to instead say B and H because I get tired of saying it. We're going to do that. So here I say, take the Yugoslavia data and then create a new variable, that is mutate. I want to create a new variable called short country. This is just going to shorten Bosnia and Herzegovina down and leave everything else alone. The result of this, that is, what is short country going to be equal to, is the result of an if-else statement. If our country is equal to Bosnia and Herzegovina, I want it to be B and H. That is, I want short country to be B and H. If country is not Bosnia and Herzegovina, I want it to be the original value of country. Notice here I say as.character country. This is because country in the Gapminder data is a type of data called a factor. And if I want this to come out as character data, which this is right here, I'm going to have to convert it to character now. Often you'll use factors and try and do some of these things and you'll get odd results. For instance, something might pop out looking like numbers instead of the name of the country. That's probably because your factor was converted to something or is numeric under the hood, kind of, and was converted to those numbers. As character, we'll make it go to the country name. Just know that you need to do it. I would recommend experimenting with this to see what happens if I don't do as.character and things. Okay. So I then say, just give me short country, year, and population, and look at my data. Bosnia and Herzegovina is now B and H in short country, but Croatia and Montenegro remain the same because I just said leave them the same, basically. So this is a way that we can basically change one value in some column and leave all the rest of them the same. This is a common operation with if-else. Another thing that you'd commonly use if-else to do is create a binary indicator variable of something. That is a dummy variable of something. You might say something like, well, I'm going to say it's a high crime neighborhood if it has over like 30 assaults per month. I would say if assaults are greater than 30, high crime, otherwise low crime. And now I have a binary indicator variable indicating high versus low crime. If else is great for that. Okay. That makes sense? This is one I recommend playing with. It becomes very intuitive when you use it, but it can be odd in the abstract.
Hey, Charles, I have a quick question. You may have clarified this before, but is it only binary functions that if-else works with?
So only, well, if-else only works with logical statements. So the logical statement can only take a true or a false. So,
oh, okay.
Yeah,
Perfect.
by default, it's either going to have to be this thing or this thing. But you might have some situations, say, where you want it to be, if it's equal to this, do this. But if it's equal to this other thing, do this thing. And if it's equal to this other thing, do this thing. There's a function that does sequential if-else statements called case when. I'm not sure if it's the next slide, but it's coming right up. Okay. Okay, not quite the next one. So maybe what you actually want to do is not create a new variable based on a logical statement, but you really, especially in a factor, just want to change one of these values. So recode is a function you can use in Mutate. And what recode does is it will change a specific value or multiple values into some other value, okay? So in this case, I'm showing how without converting a country into a character, that is without doing my statement I did in the last slide, how I could modify it right in that country variable. Here I say, take the Yugoslavia data and then mutate country. So I'm actually going to overwrite the original country variable just for a minute. I'm not assigning it back to Yugoslavia, so it's not going to be permanent. But for the rest of this, it will be, you know, just until the end of this code, it will be changed. I'm going to say overwrite country with the result of recode. What we're going to recode is the country variable. And this says, anytime you see Bosnia and Herzegovina, so this is the original value in that column, replace it with B and H. And also, if you see Montenegro, replace it with M, because I've got some beef with Montenegro, okay? Then I get the distinct values of country, and we see Bosnia and Herzegovina has been changed to B and H, Montenegro to M, everything else has been left alone. And the other thing you'll note is the country variable is still a factor. I haven't converted it to a character column like it is over here with short country. Okay, so there are some times when you want to work specifically with factors and keep them factors the whole time you're working with them. We're going to get into some examples of that, especially in week 5, because factors control the order things are plotted and assembled often in tables. Okay. Okay, so about the sequential statements that I was talking about earlier, that is doing multiple if-else or if-then type statements, we can use case when. Case when is my favorite function in the dplyr package. I love this, and it ends up in every project I use because it is super useful. I did not discover it was in dplyr until I'd been using dplyr for like a year and a half, and I'd been using stupid methods to do this. And once I discovered this, I punched myself in the face a couple times, and then I started using it in every project that I have. Okay. So what case when does is it allows you to perform multiple if-else operations. I say at the same time, but they're actually sequential. Okay, so case when can be used to do things like create a new variable, maybe an ordinal variable from a continuous measure or series of measures. I'll show you an example of how it works because it's clearer to show you an example than explain the way it works. Okay, so I'm going to take my Gapminder data and then create a new variable called GDP per capita ordinal. It is going to be equal to the output of case when, And then inside this case when, we write a bunch of statements that we want to produce trues and falses. So I say, if GDP per capita is less than 700, assign the value low to GDP per capita ordinal. If this returns a false, it will go to the next line. If GDP per capita is above 700, it goes to the next line. And then it says, if GDP per capita is greater than or equal to 700, but lower than 800, assign moderate to GDP per capita ordinal, okay? If this is not true, and this is not true, it will go to this one. Well, this one is always true. Because it's always true, anything that makes it through this statement and this statement just gets assigned high GDP per capita ordinal, okay? Then I select a series of rows down here in Afghanistan, and you'll see Afghanistan, when it had a GDP of 786, that is between 700 and 800, it got moderate. When it was over 800, it got high. Over 800, it gets high. And then when it was below 700, it got low. So this sequential series of statements let me create an ordinal variable out of this. The cool thing in case when, though, is you can do any type of logical statement, anything that produces a true and false, and you can use any variables you want. In this example, I always use GDP per capita ordinal, but you could use multiple variables in here. You could test one variable and something else at the same time and produce a value based on that. You can do incredibly complex tests in here, and it will generate variable values for you. The one caveat to case when is case when does not like encountering NAs, because an NA in GDP per capita can't be tested against 700. If you have missing data in some column, you'll want to put as the first line something that assigns to NAs a value. So it would just say something like is.NA GDP per capita, assign NA to it. You just need to catch your NAs, okay? If you need help with that later, let me know. We're going to use case when a couple times in this class with NAs, I think, so you'll see it in action. Okay, so this is a really cool function, but it's complicated. If you put it into action, you need help with it, of course, reach out to me, but this is a really powerful and useful one. Okay. So Lauren asks, can you talk a little bit about what types of variables, numeric, factor, etc., go with which types of NAs in those situations? This is an excellent question and a sneaky one because most people don't realize that NAs, that is a missing values, carry full type information in them. So if you go into R and you see like an NA, that's a missing value, right? Okay, that NA is a type of data. If I say class NA here, it's going to say it is a logical, because by default an NA is a logical value. Logical values are trues or falses. This missing value is in fact not a numeric missing value, it is specifically a logical missing value. You can specify in R the type of missing value you want by saying NA underscore, and you'll see there are different types of NAs. There are character NAs, complex NAs, integer NAs, and real number NAs, okay? So case when is particular about the type of NA you assign. If you're creating a character variable, you need to assign to it a character NA. If you assign a NA to a factor variable, you probably actually want to assign an NA level to it, but factors are actually a numeric variable, not character, so you'll have to assign to them, I believe, either real or integer. I think it's integer, but I don't remember offhand. For most numeric things, you'll assign a real number or an integer number to it. Okay, this is complex and rarely is a problem because the way R works, unlike most programming languages, is it just changes the type of data on the fly to do what it thinks you want. Case when actually forces you to choose this, which is why I said if you run into problems, ask me for help because I can tell you how it works in your application. That is a really good question though, and a weird thing kind of about R. You have to specify the type of the missing value. Well, you don't have to. R will usually just do something for you. 9 times out of 10, what R does for you ends up being the right thing. That other 1 out of 10 times is very confusing. Okay. Any other questions? Lovely. Let us continue. Okay. Another function in dplyr that's sort of useful once in a while is the pull function. Sometimes what you want to do is you want to do maybe a bunch of operations on your data, but you actually want to extract from your data a single column as a vector, not a column of a data frame, but you want to pull it out so it's a vector, because a lot of functions in R take vectors, but they don't take data frames. The pull function does this. If I say, take the gapminder data and then pull life expectancy and get head, I get 28.801, 30 about that, 32-ish about, 34. These are the values of the life expectancy column, but extracted as a vector. They are no longer a column in a data frame. If I say gapminder select life expectancy, I also get only life expectancy, but the data type of this is a tibble, which is a type of data frame. It remains a data frame, and it's a column here. If I took mean of this, so I sent this into the mean function, it would calculate the mean of the life expectancy variable. If I sent this into the mean function, it would yell because mean can't take a data frame as an argument. Okay? So pull is when you want to yank out a column of your data frame to use it in some function that only takes a vector. Here's an example of a time you might want to do that. So maybe what you want is some inline statement in your R code, like you want something like text that is, the average life expectancy in Afghanistan from 1952 to 2007 was backtick R, take the gapminder data, and then filter to Afghanistan, and then pull life expectancy, and then take its mean, and then round it to one decimal place, years. This would produce output in your document of the average life expectancy in Afghanistan from 1952 to 2007 was 37.5 years. If I, instead of doing pull life expectancy, did select life expectancy, it would give you an error because you can't pipe a data frame into the mean function. Okay? So this is an example of it being handy. An easier possibly way to do this would take this entire statement up here or whatever, put it in a chunk, assign it to an object, and call the object inline so you don't have a whole bunch of piped stuff sitting in the middle of your text. But you do whatever you like to. Okay. So the next section for today, I've talked as much as I'm going to talk about today about creating variables, creating columns, filtering to rows, selecting columns. If you have any questions about that stuff, shoot them to me now. Otherwise, we're going to move on to the next topic, which is summarization of data. We got anything? Lovely. Let's keep chugging along. Okay. So aggregation in dplyr, summarizing data, is mostly done with the summarize function, another logically named function, unlike mutate, in dplyr. So what summarize does is summarize will take a column or columns of your data and compute something using every row in the data frame. For instance, you might count how many rows there are. You might calculate the mean of a variable, calculate the sum of it, obtain its minimum or maximum value, something like that. So you can use any function in summarize that will aggregate multiple values into a single value. Things like standard deviation, the mean, maximum, all that kind of stuff. You can use any of those in summarize so long as the result from calling that function is one number. Let's see this in action. Okay, so let's say for the year 1982, I want to get the number of observations in Yugoslavia, the total population of Yugoslavia, the mean life expectancy, and the range of life expectancy. Okay, I say here, take the Yugoslavia data and then filter, so year is equal to 1982, and then summarize so that the number of observations is equal to n. N is a function that gets the number of rows in the data frame inside mutate. Total population is equal to the sum of the population column. Mean life expectancy is equal to the mean of life expectancy, and the range of life expectancy is just the difference between the max and the minimum life expectancy. The output from summarize is going to be one row that summarizes these data. We see the number of observations is 5 because there were 5 countries in former Yugoslavia here. The total population is this. Mean life expectancy is 71.3. The range is 3.94. So these are new variables I've created using syntax like mutate. It's the same syntax as mutate. These are new variables created, but they were calculated using every row in the Yugoslavia data. That is, they were summarized over all those data. Okay, does that make sense?
Chuck, I'm a little confused about poll and data frames and vectors.
Yeah.
So my understanding was that you can't pull out just you can't do mean life expectancy because life expectancy is a data frame, but that's exactly what you did on the next slide, is you did do mean life expectancy. So
if I had done select life expectancy here, I couldn't. So in dplyr, if you select down to a single column, the data still remain a data frame. But in here, pull lets you pull that column out as a vector. So here I've used pull because select here wouldn't work.
Okay, thanks.
Okay, so I've summarized down and created these new variables that are summaries of all the data in this particular data frame. Okay, so maybe what you want to do is, instead of summarizing one column at a time like that, what we want to do is say get the means and standard deviations of lots of columns in our data. If I wanted to get the mean and standard deviation of like 20 different columns, I don't want to type out all 20 different columns. Much like there were shortcuts for the select function, there are shortcuts for summarize. These shortcuts take the form of different forms of the summarize function. At least for now. I'll talk about at the end of this lecture how they're getting rid of summarize at and stuff like that and replace them with a different structure, but this will continue working for years. Anyway, with summarize at, what you do is you provide multiple variables you want to do summaries over, and then you provide a list, I'll talk about lists next week, a list of the functions you want to calculate on those variables. So in this case, I say, take the Yugoslavia data and then filter down so that year is 1982, and then summarize at. I want to do summaries on the life expectancy and population variables. So you see how it's in a vars function, life expectancy and pop. The summary I want to do is a list of summaries. I want to create a column called mean equal to running the mean function on these columns, and SD equal to running standard deviation on these columns. What I get out as a result is the variable name underscore the name I put here, that is mean, and this is the mean of life expectancy. This is the mean of population. This is the standard deviation of life expectancy and the standard deviation of population. So you can see as you have more and more variables you add, you're getting more and more out of this thing without adding tons more code. I don't have to write life expectancy underscore mean equals mean life expectancy, pop mean equals mean of population, and so on and so forth, and write a ton of crap. Okay. Yeah. So, yes.
Could you, if you wanted the, like, if you wanted them grouped by like the mean as opposed, and then the standard, like if you wanted them grouped by the variable and not the mean and standard deviation, does that make sense? Like, could you group them differently?
I'm not sure how you can, you know,
life expectancy mean and then pop mean and then life expectancy standard deviation. Could you group them instead by the variable as opposed to the function?
Let me check real quick. I don't remember if there's an automatic way to do that. I want to say that within summarize at, no. So what you would instead do is then use a select function afterwards or to reorder them. Yeah, I think by default, you can't control the order of them in summarize at. So it's going to arbitrarily, it's going to put them out in the order that I just showed. Yeah. I'm not aware of a way that does it within summarize at, but normally I don't actually care about the order the columns are in for the most part, but because you know it's kind of arbitrary.
Okay, no worries.
Yeah,
thanks.
But yeah, no, there's no way to do it in summarize at directly. In the next version of dplyr, there's actually a command specifically for reordering your columns in particular ways. And you'll be able to use that function to do it. Right now, you have to use select. I think rename will actually technically reorder things as well. Yeah. Anyway, good question though. I mean, yeah, that's something I've wanted to do in the past and been slightly annoyed by. But usually it's just for you to see rather than anything else. Okay. So there are other functions like summarize at to let you do some of these multiple summaries. There's also mutate versions of these. So summarize all or mutate all will summarize or mutate every variable in your data frame using the same things. So the syntax for that looks like this. Take your data and then summarize all. You don't have to name the variables because you've just told it you want to use every single variable in the data set. And then this is a different way to write the same syntax I wrote before. I'm saying here, I'm going to run a list of functions. I can provide them instead as formulae like this. Tilde mean period says, run your summary and get the mean of each column. This says get the standard deviation of each column. This is syntax from the per package, which is a package for sort of vectorized operations and repetitive operations in R. I don't teach it in this class, but the syntax is useful. The nice thing about doing them this way is you can do more complex functions in here. Like I could do mean period, like I could do like period minus mean period divided by SD period, and that would standardize the variable. So you can do multiple function calls. You probably won't often have to do it, but if you're interested, that's how you do it. There's also summarize if and mutate if. What these do is they will grab the variables satisfying some logical function in R. For instance, you could say, take my data frame and then summarize if the variables are numeric. So this would grab only your numeric variables and get their mean and standard deviation, ignoring all the categorical variables in the data. This is kind of nice if you want to do quick summary, save your categorical stuff separately from your numeric stuff. Okay. Those are ones to play with. I'm not going to go into detail, and I don't really expect you to like master them. Okay. So far we've seen that the summarize function will take an entire data frame and reduce it to a single row, right? Well, most of the time we don't want our summaries to be a single row of data. Instead, we want summaries stratified on something. That is, we want to group our data together by some variable or series of variables and get summaries within those subgroups. Right? We might want to do something like maybe we have person year observations and we want to summarize over people and just have person observations, right? For instance, in our Gapminder data, we have country year observations. Maybe what we want is country observations or even continent observations or continent year observations, right? These are summaries, but they're stratified within other variables. The way we do this is with a special function called group by. What group by does is it changes how subsequent functions operate on the data, the most important of which is summarize. So any function you run after group by will be computed separately within each level of whatever variable you put in group by, rather than over all the rows simultaneously. Normally, you're going to be doing summaries over some integer, factor, or character variable and not continuous real values, because then you only have one observation per group or something. The Excel analog to this is working in pivot tables. Or so I hear. I haven't used a pivot table in 10 years. Okay, so here's an example using group by. I'm going to take the Yugoslavia data I created and I'm going to group by year. So what I'm going to do is I want to generate summaries within each year of the Yugoslavia data. I'm going to say summarize the number of countries is equal to the distinct number of countries within that year. This will actually be the same as the number of observations, but I'm just showing you off a new function. And distinct counts the number of distinct values in that variable. The total population is the sum of population. And then total GDP per capita is going to be equal to the sum of population times GDP per capita divided by the total population. I get the head of observations. So now what we see is because we grouped by year, I have one row per year of the data, right? There's always 5 countries in each one. There's a total population and a GDP per capita per year within Yugoslavia, right? So what I've taken is an overall data frame of Yugoslavia, decided I'd like to stratify it on year, and then calculate summaries within those years, right? I could instead change this to country, leave everything else basically the same, and my rows would be one row per country with their total population, GDP per cap, and so on and so forth, right? Questions about that? Yeah, okay. So window functions. So grouping can also be used to then use mutate or filter afterwards to do things like grab rank orders within the group, calculate lagged values, do cumulative sums within the group. There's a lot of these things which are called window functions. I'm not going to explain why exactly it means. Basically, you're calculating something within some window of the data, that being a group, basically. You can read more about them in this vignette if you're interested. I will, however, provide an example. I'm going to take the Yugoslavia data here. I'm going to select country, year, and population, filter down to just years above 2002, because I just want 2002 and 2007, 2 years to give you a concise example. I'm going to group by country. Then within these countries, I'm going to calculate lag population is equal to the lag of population. Lag just grabs the previous row's value of the variable, ordered by year. So this is order by year, just specifies that I want them to be increasing in year, just to make sure in case I'd arranged the data wrong, it will rearrange it to calculate the lag. Lag pop will be last year's population. And then the change in population is going to be equal to the current year's population minus last year's population. Okay. Now what we see in the data is Bosnia and Herzegovina. In 2002, lag population and population change are NA. So the reason they're NA is because there was no observation for Bosnia and Herzegovina before 2002. The thing is, if we had not grouped on country, it wouldn't know that they row before Bosnia and Herzegovina. Let's say it's another country like Afghanistan. It wouldn't know not to go and grab the lag of population from that prior country. By grouping on country here, we say, okay, everything in Bosnia and Herzegovina should be treated like its own data frame, and there's no row above this. There's no row above this for Croatia, so it doesn't go and grab a lag from some other country. Okay, so for lags and things of a country, it's important to calculate them grouped within that country so you don't go and grab wrong observations from some other country. So a question in chat here, can you explain lag again? Lag is pretty straightforward. What lag does is it just grabs the previous year's value of a variable, like population. So lag just says, okay, look up one row and give me that value. That's all it does. You could specify lag pop, comma, like 2, and it would look 2 observations up. If you want to look the other direction, that is look at leads, the function is lead. Okay. Yeah. Any other questions? Can that make sense? Okay. We'll chug on. Okay. So the last topic for today is joining or merging data together. That is combining data frames into one data frame. So when do we need to join tables, right? Sometimes you want to make columns of data where the criteria are too complicated to do an if, else, or case when. So what you do instead is grab the variables you want to work with, manipulate them in some other data frame, and then combine them back to your original data. I do this all the time when the operations are complicated, involve multiple variables, and maybe involve some kind of weird summarization and things like that. Do it all the time. Another one is maybe your data were never in the same data frame to begin with. You have some separate data sets. So an example of this that I did recently was I had a bunch of University of Washington student registrar data and police stop records from UWPD, and I had to match student records onto when they've been stopped by the police to see how racist police are at the UWPD. Turns out not too bad compared to most police departments. Okay. Also, sometimes you'll encounter things like large survey data sets that are broken into different data sets for each level. You may have a data set, for instance, at the household, another one at the individual, and another one at the neighborhood. A common example I see of this are things like travel surveys, where you have an individual data set, your household data set, and maybe trips are in their own data set and things like that, right? Real common. Also in that Denver Youth Survey I mentioned before, there's a separate data set for children, for parents, for young adults, for adults, for schools, all that kind of stuff. You got to merge these things all together. Okay. So in concept, if you want to join some data frames together, you have to think about a few things sort of before you do the join. If you have abstract data frame A and abstract data frame B, you need to ask yourself, which rows do I want from each one of these data frames? Which columns do I want from each one, and which variables determine how to match rows between these two data frames, right? These are sort of the 3 basic things you need to know to join. okay? So there are a lot of different types of joins. If you've ever done anything with SQL, you are quite familiar probably with these different names of joins. So there are a lot and they all do different things. If you're interested, you can carefully look through these list of them, but I'll tell you right away, with a little bit of thought, 9 times out of 10, a left join does the job. So what a left join does is, if we say, take data frame A and then left join it to B, what this will do is it will keep all rows from A, that is all rows from the left side of this, and it will match them with the rows in B wherever possible, and keep all the columns from both A and B. So what you end up with is every row from A and only the rows from B that match a row in A, okay? Right join is the opposite. You end up with all the rows from B and only the rows from A that match those in B. Inner join gives you only the rows that exist in both A and B. A full join gives you all the rows in A and B. Then you get into a couple odd ones. Semi-join and anti-join, okay? Semi-join will keep all the rows from A that match something in B, but doesn't keep any of the columns from B. This is just a way to sort of reduce your data set down to something that you know is observations that exist in another data source. So maybe your B over here is a list of valid units in your data. You could semi-join onto there and it reduces A down to your valid units. There's also anti-join. Anti-join keeps rows from A that do not match rows in B and then keeps only the columns from A. This deletes things that you don't want. I have never used anti-join. I have used semi-join once. I use full join, inner join, and left join constantly, but usually left join. They're all useful for different reasons. If you're going to master one of these and be used to it, do left join and just arrange your things so a left join gives you what you want. Okay.
So do you have to, can you specify which column, or is it just the leftmost columns of each data frame?
We will specify, and that's the next slide.
Oh, sorry.
Yeah. Anticipating me. I like it. It's fun. Okay. So matching criteria, right? So we say the rows should match because there'll be some columns that contain the same value between them. There are ways to do fuzzy joins too, where they join like within some closeness, but dplyr doesn't do fuzzy joins. You'll need another package for that. So if you have things like name data where they're misspelled all the time, but you want them close, you can use fuzzy matching for that. I have some experience with that if you're curious for some application. Anyway, so in these joins, you specify what columns will be used to match them using the by equals argument. The way it works is this. If you do a left join and you don't give it an argument for by, it's going to assume that every variable in A and B that have the same column name should be used to match. So we'll just automatically use the same column names and match on those. If you say by equals and then provide it a variable name or a vector of variable names, it will match specifically on these variables. So this would say match a row if variable 1, variable 2, and variable 3 in both data sets have the same value, okay? Sometimes, however, your data sets have columns you want to match on that have different names but the same data in them. You can use name value pairs to do this. So you could say, for instance, that I would like to match by this variable 1 in data set A is equal to this variable in data set B, and this variable in data set A is equal to this variable in data set B. You could instead use this and rename your variables in them ahead of time, but here, if you want to do it all in one operation, this says if this variable and this variable are the same, match on those, okay? A thing to note in joins is that if there are multiple matches, so for instance, in this var1, var2, and var3 situation, if there are 2 rows that have var1, var2, and var3 the same, you are going to get 1 row for each possible combination, so each match of these, except where semi-join and anti-joins take place, okay? So if you want this to happen, that's great. So for instance, if you want to do something like, let's say you have a data set of individuals in your data frame A and neighborhoods in data frame B. If you have multiple individuals in a same neighborhood, you want to get one row for each of those individuals. That is one row for each match, right? That's great. Sometimes you do not want this, and you should be aware of it. If what you're interested in is individual neighborhoods and you're matching them onto people with the expectation you only have one person per neighborhood, you probably don't want these multiple matches, and you need to figure out how to shape your data so that doesn't occur, okay? Yeah, if you need to get more complicated than these methods of matching that are in here, I would recommend breaking it into multiple operations or learning SQL, because SQL is sort of the language for making table joining type operations. It's very good for this sort of thing. So here's a question. Eli asks, if you are working with text data and weird spaces in your observations, will R be able to distinguish the match values despite the leading or annoying spaces? We do ideally clean it before doing a join. You would indeed need to clean it before doing the join. We're going to learn a lot about string manipulation and text cleaning in week 8. Yeah, week 8. So we'll get there. But yeah, you'd have to clean it first because these are exact matches. If you have a lot of unpredictable sort of differences between these things, fuzzy matches are the way to go. Okay. If it's something consistent, like they always just have leading spaces, I mean, some observations don't, but leading spaces are your only problem. It's easy to trim out leading spaces. If someone is capitalized, the other's not capitalized, it's easy to just like decapitalize or capitalize them and stuff like that. We're going to talk about that in week 8. If it's unpredictable, the worst one is misspellings. Fuzzy matches are the only way to do it. Next question. Can it match by dates if they're in the same format? Absolutely. Matching on dates is something I do constantly. I do it all the time. As long as they're both in date format or they're both in some character format that's identical, they can absolutely match on it. R actually has specific data formats for dates, POSIX time and things like that, which we'll talk about in 2 weeks a little bit. We'll get there. It absolutely can match on dates in date format or dates converted to text. Okay. Yeah, I do date time joins all the time. Okay. So there's a data set I'm going to use here for examples of doing joins. This data set is actually multiple data frames. This is the NYC Flights 13 package. You're going to want to install this and use this, and pay attention here because this is the data set you will use for your dplyr homework this week. So what the NYC Flights 13 data set is it is every flight, I can't remember if it's leaving or entering any New York City airport in the year 2013. It consists of 5 different data frames. They are flights, that is every flight, okay, every flight leaving the JFK, LGA, or EWR airports in 2013. Another data set of airline abbreviations that converts, though, abbreviations for like Delta to the actual text Delta Airlines. It also contains data on the individual airports. That is, every airport any flight flew to from any of these airports. It includes metadata on the individual planes. So planes in 2013, each plane will have flown many, many flights. So you have information on that particular plane, the type of plane it is, how many seats it has, how long it's been in the air, like when it was manufactured, things like that. Then there's also hourly weather data, each for JFK, LGA, and EWR airports. Okay, so note that these are separate data frames, meaning if you want to look at them in R, you need to load them individually. So you can load the library NYC Flights 13, but if you want to see each data frame in your environment, you'll need to do data flights, data airlines, data airports, and so on to see each individual one. They're separate data frames. You're going to have to make them talk to each other. Okay, so here's an example of a join using the NYC Flights 13 data. If I'm interested in who manufactures the planes that flew from New York to Seattle, I might say, let's begin with the flights, the individual flights that went somewhere from a New York airport. And then filter so that the destination is SeaTac. So the FAA code for SeaTac is SEA. Then all I care about is the tail number of the planes. I want to know who manufactured them. I don't need any more information about these flights other than knowing they went to Seattle and knowing the tail number of the plane, the tail number being the unique identifier for the plane. That's like the number stamped on the tail of the plane. I'm going to take these tail numbers and say, I want to left join them to the data frame of planes. But the only thing I care about in the planes data frame are the tail number and manufacturer columns. So note here I've done something funny. I have selected down to 2 columns inside of my left join. What this left join will do is it will join onto the result of this statement here. This is just me showing something fancy. You could create another object here and left join onto it if you want, or you can do the stuff right inside and not create any objects. I want to left join on this tail number variable, which of course, tail number has to exist in this data frame and also in this data frame to join. Then what I'm going to do is I'm going to count observations of each manufacturer. This is a function I haven't shown yet. Count just tallies things up. This is a short way of saying group by manufacturer and then count the number of observations and summarize, okay? Then I'm going to arrange it in descending order by n. N is a variable created by default by the count function. It's the count of observations in that group. The resulting data frame is a data frame with 1 row per manufacturer and a number n, which is the count of planes from that manufacturer that flew to Seattle in the data set. So you'll see most planes that flew to Seattle were Boeing planes. A lot were Airbus planes. And notice here, these are not clean data. Airbus and Airbus Industries are the same company, but they've been listed 2 different ways. If you were working with this for research purposes, you'd probably want to make Airbus and Airbus Industries the same value, right? Notice there's a lot of planes without any manufacturers. 391 planes with an unknown manufacturer flew to Seattle. Then you have things like Barker Jack, which is a private little plane company, Cirrus Design Corp, private plane company, so on and so forth, right? Okay. Any questions about that?
Just for clarification, you select by tail number. Is that just to prevent from counting the same plane twice?
So not exactly. So in the flights data set here, so this is just to get individual tail numbers, but it's not the unique tail numbers. So if, say, one particular plane flew 50 times to Seattle, this data set here has 50 rows for that particular plane. If I left join on it, they will be counted, they will be joined on 50 times to that manufacturer. So this number of counts is not 2,659 unique planes. It is 2,659 flights involving a plane manufactured by Boeing, if that makes sense.
Yeah, it makes sense. I guess I'm a little bit confused why you started out by selecting by tail number. I must just be missing something.
So no, the idea here is that I did that. I mean, I could have actually not selected it all. I could have left all the columns in the data set, but select here is just reducing it down to only the columns that I need. The idea here is that I just want to get rid of the garbage I'm not going to use. So I'm somebody who's a little bit anal about using really clean data frames, like use data frames that only have what is necessary in them. In this case, the only thing I need to match onto this other data set is the tail number of the plane. So I use select because I'm discarding every other column because I just don't care about it. It's actually, we'll get the same result here with or without that select statement technically. You could test it yourself by copying it and running this code yourself.
So if we selected by manufacturer instead, would we get the same table that you got, because we would then have it listed only by manufacturer and nix all the data that is not relevant?
So the trick here is in this flights data frame, the flights data frame doesn't have a manufacturer column. So the idea is the planes data frame has manufacturer. So the purpose of this is to get the manufacturer column out of the planes data frame, but match it to the flights data frame. So I can select on tail number, but I can't select on manufacturer here because manufacturer doesn't exist in this data set.
Oh, okay. And so when you select by tail number, there's a delay, like how they denote tail number in the flights data frame matches to the plane's manufacturer. Yes. Okay, I understand.
Exactly.
Okay, cool.
Yeah. And so the idea here is that the nice thing about this NYC flights data is if the columns have the same name between the data sets, they also have the same format. It's not going to do any shenanigans to you where it's different data and different ones. But yeah, this is just, so the thing to do is if you want to figure out what you want to join together in these data, you can just look at each data frame and you'll see what columns are common between data frames and which columns are not. And then you think of the columns you might want to bring from one data frame into another one. So this is an example of doing that.
Right. Thank you so much, Chuck.
Yeah, absolutely. Okay. Any other questions?
I have a question about displaying. So if I was presenting this information, let's say I've already cleaned it and now Erebus is collapsed.
Yeah.
I feel like usually you put an unknown or a missing actually on the bottom, regardless of if it's actually, like here it's in the middle because it's descending sorted, but is there a way to put that row 4 on the bottom?
Yeah. So if you want to put, well, there's a couple things. So you would basically be able to choose between sorting it by N or sorting it alphabetically, and alphabetical would put the NAs in a particular spot. If you want to have them in descending order by number, except have the NAs at the bottom, you will have to do some slight finagling with that. So you basically have to move this particular row to the end of the data, which you probably have to do manually.
Okay, thanks.
No. Okay. Great question, though. That's the type of thing I do. I'll put my missing values at the bottom of the table, and it's always annoying that I have to do it manually. I should really just write a function that does that automatically. Anyway. Okay. So here's another example. Maybe what I want to know about is which airlines had the most flights to Seattle from New York City. And I want the airlines in their full airline name. So I could take the flights data frame, and I'll note the flights data frame has the abbreviation of the airline, but it does not have the full name of the airline. So the thing I'm going to do here is match the full name of the airline, which exists in the carrier data frame, back to the flights data frame, or rather the airlines data frame, not the carrier one. So I say here, take the flights data frame and then filter. So my destination is Seattle. And then in this case, again, I only care about the carrier, so I discard every other column. Carrier is the only column I need to match onto airline, so I just discard down to it. Then I say I want to left join to the airline's data frame by carrier. So the carrier column exists here, carrier exists inside airlines, I can do my join. Then I say group by the name. Name is the name of the airline, which I know because I looked at the airline's data frame. You'd have to look at the data frame yourself to find this out. I'm going to group by name, and then I'm going to tally. So group by a variable and then tally does the same thing as count this variable. I'm just showing you another way that you can sort of do these quick aggregations. This is a shortcut again for summarize by, or group by name, summarize n equals n the number of observations. Okay, so I can use tally here. I then arrange again by descending number, and now we see that the carrier that flew the most flights to Seattle was Delta, followed by United, Alaska, JetBlue, American Airlines, and so on. Okay, so this is again sort of getting some useful information that required putting a couple different tables together, so joining them together. All I'm going to ask for in this homework is doing things roughly on this level, nothing too crazy and complicated. But if you want to do things like multi-way joins, like grab things from 3 different tables, smush them together and present it, go wild, experiment with whatever you want. Okay. Any questions on this example? I've got another one. Okay. So join example number 3. This is a more complicated one. So maybe what I want to know, is there a relationship between departure delays of flights and wind gusts at the time of departure? Okay. For this, I'm going to end up plotting the results. So I load up ggplot, but then I say here, I'm going to begin with my flights data set, and then I need a lot of columns to do this join. I need the origin because weather is specific to the airport they flew out of. I need the year. Well, actually, technically, I don't need the year. They're all 2013. I don't even know why I put year in here or why they have a year column, but they do. But I do need the month, the day, and the hour of the day, because the flight or the weather data is in month, days, and hours. And then because I'm interested in departure delays, I need that flight's specific departure delay. Then I say inner join. So the idea here, if we remember in inner join, what an inner join does is it keeps only the observations from the first data frame and the next data frame that match. So it will throw away all the rows that can't be matched to weather data because there are a bunch of missing weather data. data. And then I need to join by a lot of things. I want origin-specific weather. I join also on year, even though in this data set I technically don't have to. I join on the month, the day, and the hour. So this means the observations I'm going to get as a result are going to be month, day, hour, airport observations, right? That's a lot of observations, right? I'm going to get just multiplied out massively, okay? Then I'm going to select only what I care about, the departure delays and the wind gusts, okay? Because what I'm interested in is the relationship between these two things. That's all I need to do it. I remove some rows that have missing values. So if you're interested in how you remove rows, so you filter out rows that have missing values for a variable, this is the way to do it. I say, find rows where departure delay is NA, but then I filter so that they are not NA. If you remember, exclamation point means not. Is NA departure delay would return a true anytime this is missing. Exclamation point reverses that and returns a false. Falses get dropped. I also say, give me only rows where wind gusts are not NA, and then I pipe it straight into a ggplot. So this is an example of doing a lot of operations. I started with one data set, grabbed specific columns, joined it to another data set, grabbed specific columns, filtered the data, and sent it straight into a plot without ever creating an object. This is one of the nice things about pipes. You don't need to create anything if you don't want to. I say my x-axis is going to be wind gusts. My y-axis is going to be departure delay. I want a scatter plot, and then I want a smooth line through all of these points. What does this look like? So this is the relationship between wind gusts and delays in the original version of this data. The version that you download if you do install.packages NYC flights 13 does not have these problematic observations. So because all three of these airports were in New York and not on Venus, we are pretty sure there are no 1,200 mile per hour winds being observed, okay? So these are an example of doing some quick visualization that highlights there is a serious problem in your data, right? We should not be detecting 1,200 mile per hour winds, ripping buildings off of their foundations and sending them into low Earth orbit. Okay. So if we wanted to do the exact same operation, but get rid of those high wind gusts, which I will again remind you, you don't have to do because the data set's been updated. Like a year and a half ago, it had these problematic observations. They're gone now. We could say filter so that this is not NA, this is not NA, and so your wind gusts are much more Earth-like, below 250. Okay, otherwise the exact same plot, tweaked up a little bit with a theme black and white. And then this ends up being the smooth relationship between wind gusts and departure times, which is kind of odd. It's not perfectly linear. For some particular reason, it kind of goes up linearly like this, and then departure delays are low here, and then they go up. I haven't actually done any subset analysis to figure out why it is. It might be that one of the airports consistently has high wind gusts or something like that. I'm not entirely sure. Okay. So these are some suggestions. I say tinkering suggestions, which also mean homework suggestions if there's something you want to do in your homework and you need ideas. You might ask questions like, what are the names of the most common destination airports from each of these? Which airlines fly from New York City to your own home city if it has an airport, unlike my home city? Didn't even see a plane until I was an adult. Is there a relationship between departure delays and precipitation? You could do things like use time zone data in airports to convert flight arrival times to New York City local time and figure out how long flights took to get places. You might look at the distribution of arrival times for flights leaving New York City over a day period or something. Yeah, there might be, are there especially late or early arrivals for some regions or some airlines? Yeah, so I will give you a warning though. Flights has 336,776 rows. If you do a sloppy join, like a full join on things with multiple matches, you will get a very large number of observations. This might result in things like your computer screaming and catching on fire as you have billions of observations in your data frame. Be careful with that. This is a reason I suggest in RStudio telling it not to save your current workspace on exit. If you happen to load a data frame that is, say, the exact size of your memory, and then you close R and it attempts to reload it when you open RStudio, you are stuck with that without manually deleting your workspace. This is a thing to avoid. Okay. Yeah, so big joins, especially like Cartesian joins, that is joining every observation to every other observation, will rapidly fill up the memory on your computer. Try to avoid doing that. But if you do, it's an experience for everyone. It should happen to everyone at least once. Okay. So a quick side note added to this lecture specifically for this term, we are in an interesting time for dplyr right now. So in a few weeks, in 2 or 3 weeks, the 1.0 release version of dplyr is going to finally come out. So dplyr has been around for years and years and years, but the 1.0 version is finally coming in a few weeks. So some of the things that we've used or shown in this lecture today are going to change in dplyr 1.0.0, okay? Nothing is going to be deleted, but some functions will be what is called deprecated. That is, when you use them, a warning might pop up saying, there is now a better way to do this thing in the new version. I didn't include it because I didn't want everyone to install the buggy pre-release version of dplyr and then try and go over the stuff, but just know that some of these things, new things are going to appear. These are links here if you're interested in all the new things that will be appearing in dplyr 1.0.0, right? So there are things like new summarize features, things you can do in summarize you can't do in the current version of dplyr. There are modifications to the select and rename functions and a new function called relocate, specifically for moving variables around in your data frame, like I was talking about earlier. There's a new function called across. Across will replace summarize at and mutate at and stuff, and you'll just use it in summarize or mutate to do the same operations, reduces the number of functions that exist. And there's also a sort of renovation of row-wise operations. Sometimes what you want to do are calculations over a series of rows or observations from multiple rows. There's now a row-wise thing that works kind of like group by to do those operations. If you're interested in these things, and you will be when dplyr 1.0 finally comes out, you can go through and see what these are or ask me questions about them. I'm not yet familiar with these things because I haven't installed the development version of dplyr. That's the sort of thing I would have done right away, but I'm teaching a class this term and I don't want what's on my computer to be different than what's on your computer. But soon it will happen. Okay, so your homework 3 is just to pick something or some things to look at in these NYC Flights 13 data and write up a .rmd file showing your investigation, right? Same format as before. Upload the RMD and the HTML. I just ask that you use at least once mutate, summarize, and the group by functions. Ideally, use them multiple times. I want you to have at least one nicely formatted plot and one table with Pander or whatever else you want to use if you've gotten fancy and you start working with GT or something. Use nice variable names. Maybe try out spaces in your variable names. Round your values to a reasonable number of digits. In this case, unlike the previous 2 homeworks, include all your code in your output documents so the person who reads the HTML can see it. So echo equals true on every single chunk. Use some comments in there, maybe line breaks to separate commands so it's clear and easy to read. Write up observations in words too, but short. We're talking like a sentence or 2, the most basic stuff necessary to be like, this is what I'm doing. Yeah, and one more reminder, again, NYC Flights 13 is multiple data frames. So you load the package, but then you use data airlines, data airports, data flights to actually see them. Okay, that's it for today. Your homework grades I should be able to do within the next couple days for the first one, put them in, but I'm not 100% sure. I'm teaching some workshops on the weekend that I should probably prepare for, so I might not get to them, but I will try. Okay, any questions? There's one in chat here. So to clarify, do you want one each of mutate, summarize, and group by? Yeah, yes, one each. So you could do one mutate, you could do one summarize, and then like one group by, but group by doesn't really do anything unless you mix it with a mutate or a summarize. So you'll probably have at least 2 mutates or 2 summarizes. Okay. Anything else?
I have a question unrelated to what we're doing today, and apologies if you already went over this maybe in week 1, but in some of the like help files I've been using online, I've seen where you can write in some kind of code so that if there is an update to a package, instead of having to like reinstall a newer version, that you can just put it in your like RMD file or your R script automatically.
In what way?
Did that make sense? Just so that like when you run your RMD file or your R script, that it will look for updates and install those updates if updates.
Yes. You do not want to do this. So you don't want things to update unexpectedly, and that is like whenever you run a script or something like that. You really want it to be intentional when you update, because it would be really inconvenient, say, if you're in the middle of doing an analysis of something, like let's say you've got some report you're working on, you update packages and discover the syntax of a package has changed and your entire report doesn't work anymore. This is a thing that happens, and when I say happens, it happens to me regularly because I like to live on the edge with brand new packages constantly whose syntax changes all the time. So I tend not to update packages while I'm in the middle of a project, because sometimes chaos will reign. Yeah, you don't want this automatically. It is good to regularly update, but usually you want to update when you've set aside some time for it in case things go haywire. So it is entirely possible that, for instance, like when dplyr 1.0.0 comes out, I would recommend updating when you're ready for it, because you don't know how long it's going to take you to get back up to speed or something. You don't want to like update while you're in the middle of prepping a homework assignment and suddenly realize shit's just breaking constantly. Yeah, so you probably don't want that to do it automatically. People who run like servers with R on them will often have update packages run as a like batch file at night all the time, which is a good practice, but that's like on a server side. I would not recommend that for personal use unless, you know, you have like, you know, if you're like me and you've got like a Death Star workstation at home that, you know, everything's automated on. But yeah, I wouldn't do it, and especially not in Markdown documents, because you don't want to send a Markdown document to somebody else, have them like knit it, and it unexpectedly modifies things on their computer. So normally Markdown documents prevent you from having things like install or update packages in them at all, but sometimes there's ways to bypass that. You do not want that to happen. It will make some people very upset.
Thank you.
Great question though. Here's a question. Is in case you update a new version of a library and it's not looking good, is there any way to go back a version? Yes, the answer is yes. So in install.packages, you can specify the package version you want. So you could then look in the R archive network, like on CRAN, and see old versions and just select the old version. So if I hop over here and go to install.packages, get question mark on it, you could see there is a, where is it? There's an argument for package with version. Probably lists it down here. I always forget exactly how to do it, but I think there's a good example down here. Of course, there isn't a good example for it. Yeah, that's one of those ones that's fast to Google, say how to install a version. Typically, you rarely have to do that. So what happens is it's rare that a new package that's on CRAN has any real problems with it. It's usually just syntax changes. So that's a little bit different. Like dplyr, all your syntax probably won't change, but some other packages, sometimes they change stuff. But yeah, you can go back a version with by specifying your version number. I think you actually may have to specify it in the number. It's something odd like install.packages, it'd be like dplyr, and then you might have to do some weird thing like a version number or something. I forget exactly what the syntax is. Google it, figure it out. I've never had to do that myself, but yeah. Any other questions?
Can we go back to something, this is weird and a long time ago, slide 23? It was the one where basically it was like you went through mutate, and you mentioned that basically, so you like, you took Yugoslavia and then you were going to mutate it, and you took the column, the country column. And then you said you basically like held it, you like pulled it temporarily, and then.
So like, it's I shouldn't say that I held it temporarily. So what I did is I took Yugoslavia, I overwrote the country column with a different column, so a recoded version, right? So I just overwrote the country column entirely. The thing is because I did not assign the results of running all this back to Yugoslavia, those changes weren't saved. They didn't get rewritten to the Yugoslavia object.
Gotcha.
Yeah.
Okay.
So in R,
So
no
you would have
changes
had
are
to-
saved unless you overwrite.
You would have needed to basically assign this whole thing to Yugoslavia using one of those fun arrows.
Exactly.
In the push through, like and I'm terrible with language, percent arrow percent thing, the
In pipe?
the piping method, is it more common to then pipe it into an object at the end rather than starting with an object in the beginning?
No, typically you'd start with an object and an assignment operator and then run all the piping. So
Okay.
that would be the typical, and I'll kind of give you an example of like a larger one that kind of shows how I would do it. How about, I'm trying to get something that's not truly terrible. This might look like darkness. Let's see. Yeah, so I tend to do, so these are actual reports of mine. So for instance, I'm going to create an object here called survey base, which is going to be the basic data for a particular survey I have. And you'll see it begins with the raw survey data and pipes. So the assignment is done up here, and then you can see how many commands are run on it before the object finishes generating. So I've got a couple pages of commands run in order on that. But I do the assignment at the top so I know what I'm creating, and then the rest of this is just the syntax necessary to generate it, right? That's typically how I would organize these things. Same thing right here. Yeah.
Is there a reason not to put it at the end?
No, it's purely stylistic. If you wanted to put it at the end, you'd have to switch this. So you'd have to have an assignment operator go in the other direction like this. You could totally do that. And there are people who do that. It's just different from the standard R style guides. So it is stylistic, but there are standard ways of organizing your code, and assignment at the top is the standard R style.
Great, perfect. Thanks so much.
Anything else? Okay, we're 2 minutes over time anyway. So thanks for coming, everybody. I hope you guys have a good continuing days don't really matter anymore term, and I will see you all on Monday. Bye-bye.
Thanks so much. Bye.
Thank you. Bye-bye.